Hi. So I guess one thing that I have to say it before, because those of you may have already submit your homework, and then when some people will notice, those who are deadline fighter will notice there's some changes in the website. Is open source foundation. They actually changed the way that they put their the CSV file. So instead of download, you have to download . So that has to be changed a little bit to your data. Doesn't matter if you submit your assignment, just keep whatever they has. But if you notice that the code doesn't work, that you have to be changed a little bit, okay? And you don't have to, regardless of what you do is fine. You don't have to change it. So you just submit. If you submit, it's okay. If you find the code you can't run, then just change that part. Okay. So that would be something I want to let you know. So about this case in our slide like this, but so change the download and the one swap. Okay. And so what's the goal today would be to we are almost done with this slide with some minor details. So let's go for that. And since regression is rather important, so it would be okay to some repetition, right? I mean, it's okay to review a little bit longer, but other than that, we will go to, the goal is to go to the next set of slide, chapter 5, topic 5, and hopefully hopefully we could get faster with the 5 with multiple regression, and then hopefully next class we can talk a little bit more about LISO. Some of you, I have said I don't want to cover LISO, but some of you said I should. But let me know during the break, see if I should cover LISO, because I think it's covered in other class. But if you want to know slightly more, then I can talk about that. But you'll be something about next week, not this week. Okay. But if you let me know during the break whether you want me to, otherwise I can jump to the skip the LISO, just skip this chapter and jump to the other one. Okay, because yeah, I mean, up to you what to do. I will just follow. Some of you also want me to change a bit about the I think it's the not this one, about the where's that thing? Is the where is that thing? Oh, I think here. This present order, and I locked the file. So if you want to change it, you can do it in the break here. I have to approve what you're doing, because I don't want, because we already drawn everything, so I don't allow any edit without my approval. If you want to change it, you can just put it there. I can see whether it's agreeable, okay? Because we have fixed the time already, right? So if you add later, then we run over time, then everyone will go home late. I don't want that to happen, right? So just, if you want to change it, it's okay, but as long as every constraint is binding, okay? Now, let me quickly review the regression, which, as I said, is the probably the single most important tools that you will use for data, right? It's also you do the other class, machine learning class, right? And they are just a different type of regression, right? Just like more exotic style of regression. So regression is the key behind almost everything. Okay. And if you learn logistic regression, it's a type another regression, right? But we don't have time to cover that in our class. But that would be an idea also. It's also minimizing vertical distance, right? Or there's some other criteria to do it, right? But let's go ahead. Just repeat a little bit quickly what we're doing. For regression, the purpose is to predict y given on x. Okay, it's to predict y. Our purpose is prediction. It's not cause and effect, right? So the idea is to explain y. And remember, to predict y, the easiest case is to use the average of y, right? Average of y is the best predictor if you don't have x. So what x do is to say, right? If x is deviate from its mean, right? That would explain why deviates mean, right? So what I said is this picture. Maybe I draw it, right? So if you remember the regression, x and y, right? And a bunch of point here, okay? And when you draw the regression line, what you're doing is to draw a line that best fit the line, right? And this best fit line, how do you call best fit? Is minimizing the vertical distance, right? Of course, they are called the square distance and sum of those, right? Sum of the square distance, right? That is, you are minimizing that part. And this is the best idea. And you do notice, if you still remember, is this line will pass through mean of x bar, right? Is where the left-hand side of x go to left and go to right is the same distance, right? That is called the x bar. And also you would pass through what we call the y bar, right? Which is also the distance of the y for each thing in the same distance, right? And since the line passed through the center of data, it means that we are explaining why when y is above the mean, we're saying that because of x is above its mean by how much, right? Of course, this upward sloping, down sloping will be when y is below the mean is because x above the mean, right? So that would be the prediction, right? Because it's x is the mean and y is the mean, right? Because reasonable, right? Because the best prediction is y bar, right? And x bar is the way we predict. Okay, so that would be a regression idea, right? And you do remember, beside this best fit line, the other way to do is what we call the grouped mean, or we call the bin scatter plot, right? Is to divide x into multiple category and use the average y within that group will be your prediction. So you just segregate, partition the data, or separate them into multiple group by x, and look at the average y, because average y is the best predictor, right? We just use average y based on x. Okay. And you draw a line. Basically, you reduce the model into just two numbers, the intercept and the slope, right? So that's why we call this parametric method, because you have two parameters to estimate, right? But when we have cut into multiple group, right, and average, we're not estimating anything, okay? Just a model there, okay? So that's why we call it non-parametric method, because we are not trying to guess anything there, okay? So and we said if that is the bin scatter plot, and the Lewis is the you try to allow your scatter plot to be smooth, because this doesn't allow a continuous one, right? Depends on where they are. And when we fit later, you will see we allow parametric method can be linear, can be exponential, can be quadratic. So we will talk about that very soon. Okay. And I think we have done with the scatter plot. Okay. Well, so this is the bin scatter plot here. And we learn how to do that as well. Then we also learned this is actually the model, right? Is if 0 to 1, this number, 1 to 2, this number, 2 to 3, this number, 3 to 7 is this one, right? So this is the way that we draw this is the model. And also we know we can have this type of non-parametric method, right? Whether you plot this guy, okay? And and then we go to the most standard one that you might have already learned. I mean, if you still recall, it's the what you learned undergrad, right? It's like y equal to the intercept and the beta. That's what we said, right? It's the line. And the most important part is the meaning of alpha and beta, right? Alpha is when x is 0, and beta is when x changed by 1, and that's how y would change. And this is the vertical distance square. We know that already. And remember, important part is it passed through the center of data, right? That means that you explain the variation of y based on variation of x relative to their respective means. Okay. And the model we have is the hotel data, right? Is if you get the alpha is 133, the beta is 14, it means the city center, the price is 133, and you're 1 mile away, then it's $14 less. So this is the very standard approach. Okay. And this is the regression line. Okay. And the next thing is in particular regression, you can analyze by other than sum of square error, which is the something we want to minimize. Remember, we minimize the vertical sum of square distance. Okay. And we want to, in this regression, we want to explain how each value deviated from its mean, because as I said, mean is the data, okay, in the center there, okay? So if you look at the R square will be this SSR over SST, right? This is something you have explained by your model. SST is something you want to explain, but you want to do it. This you can't do it. This is you do it. This ratio must be 0 to 1 is something how successful your regression is. Okay. And if you do machine learning or different type of LISO or whatever, I mean, R square is also one of the measure you can use to fit your data as well. Because at the end of the day, R square is the thing you want to maximize with. Of course, you can also minimize SSE, right? But you can also maximize the R square, right? Of course, if you learn machine learning, they use more than R square, you do adjust R square, which is the same thing because adjust for number of parameter there. But same idea. Still, it's just like this over this, right? It's how good is the fit, right? If this over this is 1, right? Basically, your model is just best fit there. Okay. So that is the R square. We explained it already. Okay. And these are all measurement of the fit, right? SSE is the sum of the vertical distance. And because you want to normalize by data, so you divide by n minus 2. So the more data you have, then you should not affected by this value, just normalize. And you also take the square root because of why you want to do that. I mean, you minimize this and minimize this and minimize this should not be a big difference in terms of your modeling. But the fact that if you take a square root, if you have a large sample, this will be very large. So it's the square root, everything will collapse down, so you are manageable. So you don't want to maximize over a large stuff, right? So that's why sometimes you see when you do machine learning, you would minimize this guy or minimize this guy, meaning the same. Doesn't really make a difference there. Okay. And after that, we go to a second part of our regression, which involve transformation of the variable. Why is the case? Because we saying that X and Y are related linearly, right? But indeed, they are not related linearly. We fit a linear model that doesn't fit very well, right? If they're non-linear at the background, so you want to transform data to fit it well, okay? So the main idea is if the original X and Y are related linearly, you fit a linear model that would be fitting. If the data is non-linear, you want to fit a non-linear model to fit it better. For example, let me give you an example. So if you, for example, as the data is like this, or underlying is like this, it's not linear, right? Suppose our data like this, like this, okay, like this. Of course, you may fit a line there, that would be no problem, right? And that would be the best you think is linear, okay? But if you want to fit a model like this, you may probably want to, instead of the linear, you want to fit a non-linear one, right? You want to fit a contrasted one, right? Or you want to transform the data, right? And fit the better, right? So that happened to the case of the hotel and the price, right? I don't think you would expect that the distance is linear, because when linear means that when you are 1 mile away, no matter where you start, it's the same, right? You be the distance is more important in city center compared to outside, right? The price difference of 100 meter will be very important in the city center, right? Compared to if you are in the outskirts, right? So it's non-linear, right? The price is non-linear, right? Say, for example, you can easy to imagine this case, right? Suppose consider a rent of a apartment, okay, at the center of the subway station, right? If you consider the price difference between this and 100 meter from the station, compared to the case is far away from the station, you add 100 meter. Doesn't really matter, right? If you're in a station, up of the station, compared to the case 100 meter away, then you would pay a huge premium for actually living on the subway station, right? I think the Kowloon station already exhibit that issue, right? But if you are deep inside, I don't know where, I don't want to pin down a location, maybe Gaza in Hong Kong, right? Because about the Zhangbei, right? Zhangbei, right? Zhangbei is a lot very large, but if we're far away there, if you had 100 meter, then the price difference is not that huge, right? So that would be the idea. So that means that you would want to fit this type of model. Maybe we take a log, right? Why take a log? Because log will make a smooth out the large value. Okay, take a log, right? And you squeeze the small value. Okay, so that means that the small value will be more important at the beginning, right? The large value difference doesn't really matter. So you fit very well about the price, the distance data, right? Because short distance is very important. The distance very large is very small. Let me draw a graph. Law is like this, right? If you still remember from this is something, sorry, something from high school. Okay. So this is 1. This is 0. Oh, sorry. I didn't draw very nicely. Something like this. No. Okay. So the difference in the beginning, they go up. The steep is where slope steep right here. Okay. And then it become much less, so become very flat. Right? That fit the hotel data. Why? Right? Because initial difference of distance from the city center is very large. But when you go further away, then it's not that much. Okay. So that's why they want to log that thing. Okay. And also same the price. Price may also follow that, right? Initially, difference of price initially may be around the average price. Small change matter a lot, right? If for rich people, if you ask them to say, right? Say suppose you go to Macau, right? you live in a normal hotel, doesn't really, I mean, at $100, maybe only 10%, right? But if you are living in the Londonian, right? Then you just add $100 doesn't make a big difference as well, right? So already very expensive, you add $100 doesn't make a difference. So not linear everything, okay? So that's why you will see, right? If you have more log, actually in this model, this actually you are increasing the R square from 15% to 32%, right? You take log H1. So that means that the form of the regression is very important. Okay. So of course, you may ask, how do you try those so many forms? Well, you learn machine learning class, right? You would do a cost validation and have fun with those things, right? If your goal is prediction, right? There are many ways you can transform that to make it fit, right? Of course, if you don't want to do this, right? Don't want to ask the model to do it. That is what the random forest or those kind of thing to try to allow this thing to happen, right? Regression tree, those kind of thing. But if you want to make it explicit, you should also do that. Okay, you could try mix and match and try to fit what is right. Okay, that is the idea. Okay. Now, if you remember, if you do the hotel data, if you try to do this, the standard one, the R square is 50%, right? And if you try to, it's the graph, right? If you try to take log on the price, okay, and it will be you do the R square, okay, will be 20%, so increase by 1/3, right? And then if you this is a graph, right? And if you do the price to distance, the R square is jumped to 28%. Okay, so it's also a 40% increment R square. And finally, if you do log price, log distance, okay, the R square is 30 something. I think that's a some typo to that, but when we do it, you will see the R square should be 15, 20, 28 to 34. Okay, so that means that if you have to figure out what's the right model, if you run your regression for a project, right? Think about taking log, taking square to transform it. Okay, and probably you ask, okay, how can I know which is the good way, right? Because it's unclear what you should do, right? But you can see this price and distance, right? Say looks better with a curve, right? It doesn't seem the line is fitting. Seems to be a curve thing. Then you should try to take log, right? Or you take it square. Doesn't really matter. Regardless, you should pick polynomial or take log, right? So that would be the idea. Okay. And once we did that, okay, we want to look at the example. Okay, I think that would be application to see why, how we do it. Okay, so this is the question is very interesting. Can you live? We will live longer if you have more money. Okay, suppose someone win a lottery, right? Will actually that guy live longer? Right? That's a easy question to ask, right? Of course, I think in general, yes, right? But need not be because you have more money. Maybe you spend more time on drinking alcohol. Maybe doing some crazy thing, then you just die. That's often happen, right? Because you don't do exercise and you are living in a crazy life, and that happened, right? If you that happened. And so how can you see this, right? Look at this happen, right? And turn out to be non-linear. Okay, if you look at US, right, rich country, but they don't live very long, right? They longer a little bit, but it's not that long. Okay, so we'll try to run this using the World Development Indicator data. Okay, and we can run this if we want. Do you want me to run this together? Maybe just run 101010. So let me run this data. My Python, the code is already updated according to the code changes, but I didn't update the slides. Okay, so if you run the code, should be no problem. Okay, it shouldn't be an issue to run the code, but so let me run the code down there. So this is data. Okay. So this is the data. As you will see, it's a long data. Okay. You'll be a year, country name, and code, and how long you live, population, and GDP. Okay. So that's a free thing we are studying. Okay. So this is data. Okay. And what we want to see is to focus on a particular year, right? And we want to see the GDP, okay? How the GDP relate to the life expectancy, okay? So here, we will use why I do that? Yeah, okay. I use a lambda function. Actually, I don't need that. Let me change it because, okay. Okay, maybe I should talk about, say, I actually use the easier one. We just say which year is 2011. 17, I do it. Okay. Why I use lambda function? No idea. But lambda function is actually better. I mean, I know, whatever. So it's just basically this is selecting a year. I pick up 2017, right? And I take log GDP. Why? Because later you will see it's not linear, right? Because you would think that if you're super rich already, so that is already very difficult to increase your life that much already. You eat very well because most people die is because they don't have health care, they don't have good food, right? But if you add more money, doesn't help you that much when you are rich already. So just do it. And I just sort it by GDP because that's how I plot the data. Okay. And the first thing to do, as you can see, I will use the matplotlib py to plot the data to see GDP and life expectancy. See the nonlinear thing. Let's explain why you want to take log. Okay, you see why I take log because a line here doesn't fit very well, right? Because you can see the data, right? If you increase GDP, right, it have good impact at the beginning, very low impact at the end, right? So you really fit the log idea, right? It's not the small value. The small value matter a lot, big value doesn't. So log would be fitting. Okay, of course, those of you who don't like log, you can take a square root, also work. You can take a cubic root or whatever root that also can generate the same idea. But log usually fit slightly better, but doesn't really matter. Doesn't really matter what you use. Okay, you just try to log or take a square root. Is try to squeeze this thing. So what the log is doing is try to squeeze this scale such that become a linear, right? Basically, you're just making this you just like a fan. You just like I don't know, squeeze a little bit, right? You just squeeze a little bit and make a line. I hope you understand what I'm saying, right? Just basically just push this line to here. Then you can draw a line. Okay. And the way to fit, right, beside the where am I? Where's the slide? Okay. Okay. I can fit the log, okay? Or I can also fit the maybe I plot the okay. Here is the plotting. If I, as I said, I push, what you see. If I keep pushing, this is more linear, you can see, right? And that's why, right, I just put a log 1, okay? And once I see this, actually, I can run different type of regression, okay? Okay. I see the code here. I run the spine. I want to forget about spine, okay? So what I do is I run a square term. So what I'm doing here is, because I saw nonlinear, I can also fit the log 1, but I want to do something else, okay? I want to fit a polynomial, okay? You may ask why I fit polynomial. The reason is that there's a math result saying that no matter what math function you want, as long as the function is continuous, you can always use polynomial to approximate it, okay? And you just increase the number of degree of polynomial, you can always, whatever continuous function, you can always approximate it very well, okay? Of course, if even differentiable, then it always can fit very well. If no Taylor series approximation, the calculus result is that any continuous smooth function, you can always have enough polynomial can fit it, okay? So that's why polynomial is the easy way to think, right? We can fit the quadratic one. Of course, you can go to n degree, okay? And let's see how we fit the quadratic version. So what I do is I create a new column in the data, right? Square is power 2, right? You can do cubic was column, okay? That's why I run that, okay? And what I'm going to do is run the regression. And I think now I can focus on the use the stat formula API, because I think this is easier to think, okay? So you'll be stat model, OS, how long you live, GDP, and GDP square using the data, okay? And you run this result, okay? And you will see this is how this model fits, okay? And for the moment, you probably don't care about this number, right? This is telling you that if you run the regression, this is saying alpha, okay? This alpha 1, right, is given by this 64, right? And this beta 1 is this 0.56, and beta 2 is this negative. So we say, if you have a this is the model. If this is this, it's more like this shape. If you should remember, right? If this is negative, means this okay, this is a math problem. If you hopefully you will remember, okay? So this is hopefully if you remember the math here. So you have alpha plus beta 1x plus beta 2x squared. Maybe I just okay, they have the octapennies here. That's good. Not supposed to move it up. Okay, that's good. So let me show you the math problem here. And yes. So if beta 2 is bigger than 0, you have a smile. Okay. And if beta 2 is less than 0, you have a sad face. Okay. It depends on this thing. Okay. So this is something actually from I think minutes ago for you guys. You learned it in the high school, right? High school math. This coefficient of square, it tells you whether you smile or are you unhappy face. Okay, so that's what we have here. Okay, we have alpha 1 positive. So when there's no money, they live have some life, right? And this is saying that where the location, if you recall the math, this is beta B1 is related to where the peak point is. Okay, and this tells you is happy or sad phase. Okay, the beta 2. Okay, so this would tell us, okay, this is negative, so this is sad. Yeah, this is sad phase. And positive is happy phase. Okay, and you can plot the data. It will give you something like, as I said, sad. It's a sad. It's a sad phase here. Okay. So that is what we have in the data. Okay. And so you can also allow power free, right? So you would do just itself, square, and cubic term. You can also fit that. Okay. And once you fit that, you'll be even something more crazier. Okay. So actually, if you still recall machine learning class, that is likely to be overfitting. Right? I don't think everyone would believe there's some sudden drop and go up. Right? So if I were to do the data analysis, I would not do the cubic term. I would do the square. That's the maximum I can do. Okay. And usually you would keep doing, increase the polynomial until it fit very well, right? It fit well. But this one does suggest that I would not pick this one, right? Because I really don't like going down up. It doesn't have no reason to believe that's the case. Okay. Of course, if you do machine learning, you don't care about explanation. You just care about the fit. This is still better fit. But can you able to convince the boss, okay? Convince the politician, when you're here, we shouldn't grow our GDP, okay? You should stop, right? Because otherwise we die, right? So just stop our economy, right? Close our border, no more trade, right? Probably not, right? So you don't take this advice, right? So you think this going up. Then because why? Because there's a basically this point here, right? If you don't have this point, you should have better fit. Okay. So that is a cubic term. And this is I want to say about this one. So you can fit square or cubic. That would be, of course, you can do as many as you want. You can power 4, that nothing stop you from doing as many as you want. Of course, as I said again, you can use R square to justify is it better or not, right? Because you can see if you fit square is 60%, right? And if you fit cubic, it's also 60.6, a little bit more, but not too much, right? And if there's a content is not so intuitive, then I would not pick this guy, right? And also it's very sensitive. You see the cubic, it's very small number, but cubic will just magnify a lot, right? So that's why when you fit a more complicated model, there's a risk, right, of less and less accurate, right? So that would be some issue going on, right? Same as machine learning, right? There's a non-monotonic thing goes on, right? Is that okay? I guess I already said what I want to do. Okay. And there's a spine here, but I said the spine is already in the purple line, so I can just skip that part. But I will tell you what it is because I'm not going to talk too much about that. Okay. The spine is very simple. Very similar to bin scatter plot. Bin scatter plot is what? You divide the data into, let me write that down, right? What's the spine here? Remember what's bin scatter plot. Bin scatter is like this, right? You have data here, you have a bunch of dot here, right? There's a data, right? So bin scatter is you cut the data into, say, here, right? And you, based on the average of here, this is your model, and average here is a model, right? So you divide them into two parts. This is bin scatter, right? Bin scatter, right? And the same idea go for the regression, right? Remember the regression is you have bunch of data, right? Bunch of data here, right? And you want to fit a line here, right? You want to fit a line here. Maybe use blue color, right? You want to fit a line here, right? And the spine is saying that, okay, instead of a line, why I have to fit a line? Why I have to fit a line? Why I can't do this? Why I cannot cut the data into here? Okay. And I want to fit one line here. Sorry, it's not a line, right? I want to fit one line here and one line there. Maybe this is not very nice, but something like this. You know what I mean, right? So you just cut multiple parts and you fit line one by one, and they are continuous. Okay, they're joined together. Okay, and this is called this spine. And I guess since you will learn the machine learning, right? So I just skip, right? I mean, skip means you don't have to worry about it. It's out of the syllabus. So in case you want, you can do it, but the math is rather simple. We just talk a little bit about the code, because so it's just like this one, right? And the code is just like this. You just fit this when, say, in this particular case, it's like when they're super rich country and poor country, the line is different. Because when you why you want to see that? Because look at the graph here. Is seems to be at this point, people super rich, actually they have a lot of problem. Okay, because you would think actually it's captured in the cubic case is when they're super rich, they get more money. Actually, they used to drink more alcohol or eat more fat meat, not veggie, then they just problem with getting too much money, right? But when you don't have enough money, it's here, right? So that's why you have a regression here, another regression there. Okay, so if you think that is a better way, that's what you see. Okay. And just the idea, the last line we want to put it here is what kind of functional norm to get, right? Of course, the easiest thing is use your eye. You see it's linear or not so linear. Take a log, take a square to fit one. Okay. And of course, also come from theory or domain knowledge, right? You know it's likely to be square, right? Like the distance or the prices. People is not uniformly respond to price difference. Maybe they're responsive in the low price, but not high price is not, right? Because maybe high price are paid by a rich customer, so they don't care that much. Or distance, right? And people who care about distance, the data center will be very sensitive. You want to take log, right? And that's the idea. And R square is also, I say poor, but poor means that you've not too meaningful to compare when you have square, you don't have square, right? I mean, of course, it's you still do it in machine learning, right? But the prediction cases, we will do SSE, right? Sum of square error or mean square error, root mean square error, is the way to do it, right? But of course, when I say R square is poor, because I should say you should use adjust R square, but I didn't teach adjust R square here, so that's why I say R square is poor. If you use adjust R square, then it's okay. Okay, and also you also learn AIC and BIC as well, right? No, for the regression, you will see actually I don't really see the Python code, right? there's a code called AIC and BIC. Is related to number of parameter and also SSE. Okay, and it will be something here to measure. But anyway, if you haven't learned it, that's okay. I don't want to introduce more term to you, but it's also a way to look at, to compare. So these are actually R squared, just R squared, AIC, BIC is the way to check how good the fit is. Okay, but when you do machine learning, the simplest way is look at SSE, right? Because you don't do prediction. What's the prediction goal? Vertical difference of prediction error, right? Square prediction error. Okay. But anyway, I think we finished the regression a little bit. Okay. And so we finished so many things, right? Lesson 4. So we finished two set of slides. So we will have a quiz. Next class, is it okay, or the after? I mean, you can tell. Is it? Huh? Huh? Oh, next week. So next week? Okay, next week we will do a quiz. Okay, we voted already. So next week we'll do the quiz of lesson 3 and 4. Okay. And let's a break. And after the break, we talk about lesson 5. Okay. And in the meantime, you reply. Okay. So we have 15 minutes break. Oh, voted already. That's great. So next week we have a quiz. Okay. 嗰邊翻屋企啫，標歲下個禮拜係咩？禮拜30號咩時間？30。禮拜最3號。我哋冇彩寫，你6分啦，講9成9嘅人都冇得，可以有多啲，咁搞到兩邊都好食。意思咧係我哋禮貌，好簡單。俾你心，之後俾個高俾到心你決定。即係譬如話，我俾幾個 regression 嚟問你點解邊個啊？有我睇下，揾我 model 打出嚟咯，即係話先睇拉錯係咩咯？係你做咗assignment，我識啦，你都抄嘅。我係譬如問你個 model， 佢睇呢個之後就問你 alpha 係咩啊 ，beta 係咩，邊係咩啊？跟住問你條嗰度，你個 B.B.A 要個 test 啱定係啱啊？細個條係咪嘢㗎？我係你識佢之後跌翻出嚟，之後可能係That's fine. Yeah, of course. Don't worry, I'll see you can sign it. But I think it's okay. Yeah. AI, what thing to say? I say AI using translate. With AI. I only AI scanner. Translator is okay. I know. Yeah, I should try to guess it's actually Only some, if you want, you put a bandage to but the main thing is funding. So I don't think you have to also be one thing. Only one is one or two results.
Yeah, I do have a lot of ideas of most of the process, that's by those problems. Some details. So on the the limit of time to allow little bit code, like a whole bunch of things out there.
I don't expect you a lot. You told me that you have to describe it. Yeah, something like that.
Maybe a little bit tight. Little bit tight. And for PowerPoint, it's all
Like we only can so even supply the vacancy.
yeah.
And I want to okay, but I use private these are all higher levels. That's control and that's what very interesting.
As long as
Nice story about
it's my goal. I really like to
I think you're here, right? You put in the you're 15 to 13, yeah?
Yeah, the 15 is in the
Yes, already that's one. Yeah.
Only myself. I come here and finish presentation and go home. Is that all?
No, you have to attend other people.
Oh, I see.
You are peer reviewing others.
Okay.
That's part of your job as well.
Oh, so I'm also questioning the other group.
Yeah, you'll be asked a question and write comment on them.
Write comments. Okay, cool.
So part of the assessment is not just to present and just go.
Oh, I see.
And this exam is in the second week. The second week exam on this 20th exam.
Oh yeah, is that gonna be hard? The multiple choice or just answering questions or?
Yeah, there's multiple choice, long question, and I mean all the other class will do presentation as well.
Yeah, I think so.
Because this is just try to put everything in. You learn from others as well. I think it's more fun in a part-time program because you know other people have different diverse background. You know.
That's what I'm looking for. I'm really glad to share my industry.
Yeah, everyone will have something interesting to say.
Okay, good to see.
Yeah, but if you, I mean,
yeah,
this is the only thing you have to be there. The exam also be there. If
the last,
right? So if you very busy, just attend at least the exam.
yeah,
You have to excuse yourself.
definitely not.
Yeah,
Definitely fail. All right, thank you, sir.
Yeah.
跟住咧，它上面有 Steam Jamming 嘅，比較少。如果阿可以咧，你做可能因為C 嘅 S 嘅 S 你 S 計嗰陣時，係個 S 因為我覺得有啲咁嘅係啊，你咁又講咗係係an example係啊，所以我覺得都係知道點啊，你都可以係一分享佢啲咁對先頭先所以我三時發生係嗰啲啲 S 喺嗰啲即係佢幫我嚟嗰個嚟你可以呢個邊啲可能因為喺邊個我哋初版咧，你啲直線嗰條消費應該會話係比較，但係正常啲嘅話應該我 有啲做緊啊，做咗啦，做啦，我哋做咗啦，不過唔係 part time 咯，full time。part time 做個新嘅 program，航空管理啊，所以新Master of Aviation。新開嚟嘅，呢個我都開飛機可以啊，可以開飛機啦。OK， 都幾個嘅話啦。我睇你個 TV 我最懷念邊度嚟用咗我咁大嘅 GP 做有你話有㗎。我知有知咩？係非常好，但係裏邊呢個咩成？
So let's see. So there's a question. Where does a cutoff for R squared to be good? Okay. The answer is there's no. Why? Okay. Because it will depend on the model. Okay. What is R squared? R squared is SSR. It's SSR over SST. The idea is percentage of variation explained by your model, right? So if model is good, R squared by default is high, right? And if your model have omit many things, right? You can't collect many data, then R squared must be low. Say suppose if you do regression on financial data, then those R squared can be high as 0.8 or 0.9. If you run regular regression, R squared can be very small, but it still is very powerful, right? So it doesn't have to be high, but you can compare R square by itself usually is not useful. R square is used to compare across different model, right? So suppose you would try to see under the square thing, R square is high, or you take a cubic term, is it high enough, right? Or you take the log, increase R square or not, right? That will be, is comparable across different model type you want to use, right? But you compare, say, you have data on games or data on shipping or data on movie, then compare R square of different data set is not very useful. The same data set, different model type, R square will be telling more, right? Because looking how fit the data, how fit your model is, right? But different context is very difficult to say, right? If you one model, you say R square is very high. The other model, R square is very low, but you doesn't say anything, right? Because you still say something, but can't say too much, right? But of course, if R square is just 10%, probably not good, but it really depends on context. I would not say, I mean, of course, if a high R square, of course, better than low R square. But does it say anything? Not too much. Different model, right? So when can we get second assignment? You want to pre-release that? Okay, I can try to take a look and pre-release the assignment. The reason I didn't do it because I don't know what I cut from the slide. So then if I cut those, I take away from the assignment as well. But I can try to see if in next week I can pre-release the assignment. Because the assignment 2 will be basically all regression. Probably up to before LISO. So basically it will be 5 and 6, I guess, right? Up to 6, 5 and 6, right? I think it will be number 4, number 5, maybe up to number 5, right? So maybe it will be after this set of slide will be assignment. So I think I can probably try to see if I try to pre-release the version next week. Okay. For quiz, can we have the same content? But 1 hour, then we all no need to eat bread. So maybe you can have quiz the first half an hour, then you can come late. But there's well, if 1 hour quiz, then you have 1 hour content to write, right? I'm not sure that would be. Let's see. I mean, to me it's fine, but you pay the tuition, right? So I don't want you not to learn enough stuff. But if you really prefer 1 hour, I can make 1 hour quiz. Then you're yeah, exam is also 1 hour. So if you 1 hour quiz, then it will be a lot of. So how to choose the best with the method group? Oh, the question is what's the best? It's very difficult to say, but as I said, right, that you can use R square, you can use BIC, you can use AIC, you can use R SSE, right? And they are all very similar. Okay, it's very hard to tell, right? What would the best? Okay, is on the eye of beholder, right? It's difficult to judge. It's more like art than science, right? But if you want to be fair, you want to use SSE or RMSE, right? Because you do other regression method, you other machine learning method, you also use RMSE, right? So that would be fair comparison, right? And if you want to do it, that's what I said. Okay. Just fading out now. Could you summarize what you just said in 5 sentences? So we run regression is to try to fit the data. And you fit a line, it's an nonlinear regression. And if the line doesn't fit very well, then you want to transform data. Either you do square, exponential, or other form. And which form fit better can depend on R square, SSE, RMSE. Okay, that would be something I said. Can you summarize Cantonese? Everyone speak Cantonese? Mandarin? Okay. OK, and then I try to do it. 首先这个问题，我觉得就是我们跑这个回归啊，就是解释这个因变量跟自变量的关系，就 x 跟 y 的一个关系。但是我们就回归的话，这条线就看那个每个点跟这个线的极限距离的平方，就啊我的普通话就这样子啊。So you have to bear with me. So let's do it in English. Take log because data is not linear. Yes, because they are not, because linear means if you increase x by 1, y expect increase by beta, right? That's what it means, right? But if the linear doesn't hold in this way, right? You don't think the data is linear, right? Then you have to take log or take square or take polynomial, right? That's the idea, right? Because you don't think they're really linear, right? Just like the hotel price. As I said, near the city center, the distance matter a lot because you can walk, right? But if you are already in the far in outside the city, then you are taking cab anyway or drive anyway. So the distance doesn't matter. So it's increasing and decreasing rate. Yes. Doesn't matter because it's normalized by log of the base, right? Doesn't really matter. But natural log is natural explanation because when you take the coefficient means percentage change, right? Say x percentage change matter, right? So because log is change to percentage change. I go to school by train. Yeah, that's I do. I go to school by train. That's what I do. Very difficult. Push. Sleepy. May previous yes. I will pre-release assignment earlier. I will try to pre-release next week. Then you will have 10 more, maybe 20 something days because we only have the last assignment, right? Only two assignment. The last one is optional. You don't have to. Just submit whatever you have is fine. You're so tired, you face that project. So you need your group mate to do more. Buy them good food and then ask them to do more. That would be the way. Oh, piecewise linear spy means the following. You don't fit a single line like the blue one. Okay? You tell me where you want to do it. Cut. I fit two lines. Okay? And two lines meet at the same point. So you line here and line there. So that is the piecewise linear. Is that clear? Right? Just like being scatter plot, right? You have divided into multiple parts. The pin sample is just draw here. Okay? But regression is required you to plot from here and then plot from there. Is that okay? So that is a piecewise. But of course, now it's out of your syllabus, so don't worry about that. I take it away from your course. Okay. But that is what it means, okay? Grade A, please. Okay. Oh, this is what not I expecting to see many of you thinking still Monday or Tuesday or Wednesday. Okay. I thought people working would know what day is today, but apparently it's not true. Maybe many one are doing OT as well. It's raining. Maybe they are not in Hong Kong. Regression, polynomial regression. Yeah, regression cubic. Quiz next week. Yeah, that's true. Take log. Push. Oh, I think we have bodybuilder here. People keep pushing. That's good. Now compare fit here. Random forest. Did I say random forest? R squared. That's good. The speed is okay. Not too bad. I think it's okay. Oh. So we have something like this fit. This is a polynomial fit, right? It's like this and drop a little bit and go up. Okay. If you want to fit it, right? But yeah, I mean, that's good. Usually when I run this is 50%, even I run it for the undergrad. Okay, I do undergrad. I think undergrad people are more tired than you guys. The data has look like this. I run the undergrad every day, almost every class. They look like this. 0 here, 0 here. Then there's something like this. So they're more tired than you, at least from what they think. Exponential. Yeah, they have very basically just this. Because this is a midterm week, so they have 5 to 6 midterm they are doing, okay, this week. This 2 weeks. We don't have midterm, so don't worry. And let's guess, if you go to PhD class, what you expect? PhD class, right? They have. So perhaps maybe give you a multiple choice question. One, like this. This A, choice A. Okay. Choice B, like this. Okay. More smooth. Okay. Choice C is like this. Choice D is like this. Okay. Choice E is like this. Now, what who think is A? Okay. Who think is B? Who think is C? Okay. Who think is D? You think they're too lazy? Who think is E? Yeah, you guys are right. Actually, it's E. It's bimodal. So some people think it's very tired, but a lot of them are very relaxing. So it's a E. Huh? Me? Today is always like this because I actually non-stop from 9:30 to now. In general, I'm 2 to 3, I guess. 2 to 3. Because when I'm tired, I just get coffee, so I don't feel any more tired when I drink enough coffee. So it's in general, I'm okay. But anyway, that's the data. Lyso and Rich taught in ML. Okay, yeah. I fall enough to stat after your class. Last night, I make a dream to get an A for this course. What do you think? Okay. Do you need me to arrange a date with stat with you? Who is called stat in this class? I mean, you can message me. I mean, who is called stat? The chair. So many people get a master degrees. Yes. As an economist, I would say, in general, grad school getting a boom when there's a recession. Okay. But that is not true that much these days because we have degree inflation. Okay. Every school is printing their degree. Okay. Like crazy. I mean, you look at data in China, you look at that, it's like they call inversion now. Undergrad usually is larger than the graduate degree. Okay. But now in China, many top schools, the master program is at least 2 or 5 times the size of undergrad. And PhD is like 2 to 3 times more than master. So usually we have reverse it, right? Undergrad is bigger, master is a little bit smaller, and the PhD is smaller. But now it's a inverted pyramid. Okay, it's like in many schools like this. And look at some schools, the doctoral student, okay, the current doctoral student is more than some of the doctoral student graduate in the whole history of the school. Say, look at Zhejiang, okay? I think the current is like 10, it's like 100,000. The current master person, and more than the sum of they have produced. But anyway, but CHK, don't worry. Our degree is very important. So we never print out our degree, right? So it's very limited. Every year we don't allow to create more degrees. So your degree is much better than some of the schools that on the west side of this island. They are producing a lot of degrees. So we are very limited in terms of degrees. So your degree is valuable, right? So when will the assignment release? We'll release, as I tell, pre-release in the next week. And once we're done, then we'll formally release, okay? Halloween is coming. Yeah. So let's see. You're welcome to dress up for the on the on the next class. So on the 30th, we have class. You're welcome to dress up. Not a moment. First honor, please. To be honest, I'm not sure you would care about the grade that much. As I understand, grade at your level means 0. Okay, as long almost 0. I mean, maybe you care about a little bit, but I don't think unless you want to do. No one is going to do PhD, right? The grade is not really useful at all. I think the more useful is how much you learn from this class. It's more crucial because you spend your time here, you want to learn, right? But of course, grade may be something you make you happy, but doesn't really make a difference. At least for me, the grade for me doesn't have 0 for me, 0 value for me. I mean, no. But hopefully, yeah, so far so good. Yes. Where the master degree? I do the what's the grade? I think it's average A and A minus. But in the US, I mean, I do another degree when I do PhD, I do a PhD. Then basically the class is A and A minus, so it's like 3.8, 3.9 something. But in US, it's very generous, right? You usually get you get a B plus, then you are very best student. So basically, if you get B plus in a doctoral degree, then basically you are the teacher say you failed the class, right? So you should get A and A minus. You get B plus means that you are a very bad student. I mean, they don't want to kick you out, but just okay. If you don't well, they kick you out. So mean nothing, the grade at that level. So I think same here. The grade means not too much, right? Usually you should be getting B or B plus, right? If you get B minus for me, actually you're close to the failing the class for my standard. Okay. So you should be a B is the passing mark for me. Okay. Okay. If you get B, don't think you're doing very well. Right. You should be expecting everyone is on average should be doing B plus or above. Right. You're getting B is actually failing for my class, but we're very kind. I mean, it's master level, so it's just B is what it means. Okay. Now we get to lesson 5. Okay, which continue our journey on regression. Okay, and don't worry, that will be something that should not be too difficult because we've done the regression already. So what they're doing is that the regression, the tables have a lot of stuff, right? We try to tell you more. So remember the regression result. Say pick one of them. Let me pick a regression table. Why still not there? So this is our regression table. Okay, we have done with this one. Okay, so we want to make sense of the rest of the column. Okay, this is the goal of today. We'll let you know what's this, right? And that would be expected to appear in your exam, right? That's why I asked. If you look at what I asked in the last year, right? That's what I'm asking. So, since we're doing regression, right? So expect something similar will happen, right? I want you to know how to use a Python code, Python output, right? To answer questions, okay? So If you're able to answer this question, then it should be fine for the exam, right? So that is something I would like you to know what's going on there, okay? So now we know how to estimate a regression, but the problem is we didn't know how good is your regression, right? Just a right line, but its line is good, right? Because you can always collect some data, you can always run some regression, but is regression going to be meaningful, right? Of course, you can always, for a machine learning problem, we don't have this problem, right? If you run a machine learning your large language model, you do some prediction, whether it work or not, you can judge pretty easily, right? But when you do prediction using regular data, then it's not easy to see whether the product is useful or not, right? So we have to rely some idea, what we call the hypothesis testing or interval estimate, which we learned 2 weeks ago to oppose it. Right? Remember, we learned hypothesis testing, t-test. We also learned how to do estimate interval. Remember story, do pistol and rocket launcher, right? There's an idea there. It's going to be there, okay? And we extend the idea from linear to multiple, but that is not something that you would be too much worried about that, okay? So Cook is here. There will be learn several things, okay? One is called confidence interval, right? Because when one regression, I just give you one line, right? But that's only what we call point estimate, right? But potentially you want the line to be just not one line, but a bunch of lines, okay? How the bunch of line? That is called the confidence interval, okay? And we also have confidence interval on what we predict, okay? And then we do other hypothesis testing, okay? That's what we do. Let's go quickly, okay? And remember, our rule is 2SD rule, right? All you do is I estimate our slope, okay? And I plus or minus 2SE, right? That's what you do assignment 1, right? You put I minus 2, right? But the thing is, what is this SE, right? What's the standard deviation for this guy? And turn out that if you still remember undergrad, this is the formula, but of course we don't have to care about formula. No one remember this, okay? I don't remember, doesn't matter, right? So I don't remember this formula, right? The formula come from the Python, so somewhere there, right? Of course, I teach undergrad how to derive that, but no one remember anyway, right? So because this is too simple, right? And actually there's a more complicated one. And that one is something, if you do the graduate macro, graduate level, then you would do it is we involve a very complicated matrix calculation. It's called sandwich theorem, but we'll talk about that later. But we'll rely on Excel, so don't worry. Okay. And so here is the regression problem. Okay. And everything up to here the same, except one thing is when you fit the model, okay, if you want to fit it better, you will have the yellow thing is called covariance type HC3. If you run data, that is actually the robust standard error. Okay. And why to do that? Because I can't explain easily. The thing is this thing you learn in the undergrad, if you still remember, doesn't work very well. It's not robust in the sense that okay, what is this? Okay, what is this simple means? The simple means the following. The simple means, remember our regression, like this, right? Bunch of point here. Okay. The simple means the following. You have a regression line here. Okay. Simple means that you would believe that, remember, our model is y equal to alpha plus beta x plus error term, right? This error term is to explain why you have going up and going down, because this is capturing in the error. Error is the term that doesn't eat your model, right? And the simple standard error is assume this epsilon, okay? The variance of this guy is always a constant, okay? That means that if you assume normal, it will look like when you go to here, it will be a bell curve look like this. And when you here, it's a bell curve look like this. Okay. The assumption is for each point here, it may be here, maybe here, maybe here, maybe this point, but mainly it's this area, it's a bell curve. Okay, you read in this way. Most likely is here, more likely is that. Right? And the standard model when you learn undergrad is saying that no matter where you are, the shape is the same. Okay, it's a strong restriction. If you don't want to have this restriction, we'll use what we call the robust standard error. Okay, if you don't do that, it's called non-robust. Okay, and this robust is, in general, you always have to assume it. Okay, and you don't need to do it because in old days that is not discovered, right? This robust standard error is discovered in the 80s by economists, but is discovered way back in the 40s and 60s by statisticians. Okay, mathematician has already invented already, but economists rediscovered that. Okay, so that's why. Okay, and that's why when you look at this, XC3, you appear here. Okay, and you see XC3. It means that you have XC0, XC1, XC2, XC3. Okay, XC0 is the one non-robust. XC3 is the one that usually used in economists and social science, and some statisticians would prefer XC1. Okay, so if you try to ask AI, they always give XC1. But if you go to social science, economists, business school, they would use XC3. Okay, so don't be surprised if you look at your AI, they tell XC1 because that's engineer, they would like that. But doesn't really matter. But we'll use XC1, XC3. Okay, and XC3 is estimating what? It's estimating this column, standard error. Okay, this will affect the standard error. Okay, because XC3 is estimating the standard error of the error term, right? And this error term will determine how good is your alpha, how good is your beta, right? This is alpha standard error, beta standard error. All right. So why you care about this SE, right? Because this plus minus 2 of this will give you this value, right? No, not exactly 2, but there's some adjustment, but you can imagine, you can check this plus minus 2 times this should be very close to this 2 number. Okay, so that means that what? Your alpha is 3.6 here, right? This is a point estimate. If you want to say the interval will be between these 2 numbers, it's our interval estimate. Okay, and same for this, right? This is our interval estimate. So that's the CI is given by that model. It's 2 times of the standard error, right? So this explains this 2 column here. Okay, just to make sure I don't lose you, right? So this guy, maybe make it bigger, right? You see that more clear? Yeah, that's great. Then move a little bit. So this is a regression, right? Y equal to alpha plus beta x, right? And this is estimate your alpha, right? Or sometimes you got alpha hat, right? That's the estimate, right? This is your beta hat, right? This is the beta estimate, beta hat, right? This hat refer to the number we try to guess what's going on there, right? I guess, okay. And this number is SE, right? Standard error. So this is the standard error of alpha hat, right? And this, right? This will be very close to alpha hat minus 2 SE of alpha hat, right? And this very close to alpha hat plus 2 SE of alpha hat, right? Same for the beta. I'm not going to write it, but that will be same for the beta. So this is something that you can read from this table, right? So this is point estimate. This is 95% confidence interval, right? So I think this is hotel data, right? Is it hotel data? It's hotel data. Is it? I forgot what's the data. No, it's not hotel data, just random data there. Okay. So that would be the answer. Okay. And is that okay? Of course, this is a very bad regression. R squared is close to 0, but because I make up this data, right? So we will do the real data, then you see better. Okay. Is that okay? So now we know the interval, common interval, right? So what is left is hyperbolic testing, right? We run the regression. We really want our regression coefficient are not 0. If we are 0, say beta. If beta is 0, then our model means nothing, right? Because X is not useful at all, right? That's why you need to check always when the regression is beta 0 or not 0. Okay. If beta is 0, then basically why you need X, right? Y is done, right? It's just need Y. Why you have to use X to explain Y. Okay. And this is t-test, right? Minus the mean over the SE, right? Okay. So this column divided by this column will be this value. Right. Let me repeat. I maybe write that down. Because it seems to be except those a student who loves that so much are not nothing a lot, but so this is A, this is B, this is C, and then C is equal to A over B. Okay. And this is the t value, right? And if you remember, our t-test is 0 is here, right? And we have the t table, right? Right. Remember what we're doing is the beta 0 is here, right? You want to check this one. Okay. And this is a very small number here, right? Our beta is here. The question is this distance is larger than 2 SE or less than 2 SE? Right? That's the question. Right? Remember, this is very close to 0, but are they close enough? You look at the distance between them. Is it more than or less than 2 SE? Right? And you look at this, the distance divided by the SE means it's 2. Right? Sorry, it's not on this side, right? Sorry. It's on the other side. So the beta is on here, right? The beta is here. So the question is whether that's close enough. Look at, is it 2 SE or beta, right? Hat, right? Is it bigger than or less than, right? If it is more than 2 SE distance, then it's far away enough from 0. Okay. And you look at this over this is very small number. It's not more than 2, right? So it's even closer, very close. Okay. So not if 2 is here, right? If 2 is here, and it's somewhere here, right? It's not far away enough because 2 and -2 are cut off, right? So it's not far away. So that's why you can't reject, right? Or you look at the p-value, it's not less than 5%, right? Then you can't reject. Okay. Two things. Either you look at this Z, is it more than 2 or less than -2, right? Or look at this p-value. Is it small enough, less than 5%? If either of them would work, then this is different from 0. Okay. Otherwise, it's not. Okay. If this is not different from 0, unfortunately, this case actually is so rubbish. Basically, this model will flow into the rubbish bin. Okay. Is that clear? So that is the step you do once you run the regression, is to check this thing. Okay. Of course, the other thing you can see is our beta actually includes 0, right? If from -2 to +2, 0 is inside. Same idea. You will not pass the test. Okay. The actual theory to check, right? Either you check the column C more than 2 or less than -2. Method 2, check this guy, this column, less than 5% or not. Last method is 0 within this interval, right? If 0 is within this, then your model is rubbish, right? Because 0 is included in your prediction, right? We want to be away from 0. Okay. But all of them are the same. Okay. You should not get different result from either of them. Okay. But of course, in exam, I likely ask all of them, right? But I don't know which one will ask, but this is the thing that you should know how to calculate. You understand what's going on in each thing, right? So this is the standard error, right? It's looking at how fat is this beta, right? Okay. Because this design, right? And this is deciding where in this one, right? More than 2 or less than 2, right? And then this is the p-value, looking at the area, and there is the case. Okay. So that would be something is very important, because this tells us whether the model can be used or not used. Okay. And you don't have this for machine learning. You can't say this for machine learning, because machine learning is not a probability model. You don't have this, you can't have this judgment, because machine learning is not a probability model behind. Okay. At least as far as I understand, there's no such thing exists. You don't check the p-value, this kind of stuff. Okay. Because it's not estimating any model, right? Because it's fitting the model, right? Remember how you do machine learning, right? You just minimize SSE. You are not estimating anything. Okay. But here is estimating the model. Okay. Okay. So make sure you know how to do all this, but don't worry, you will be, our assignment will include that. So because it's so important, you will be there. Okay. And here, the slope already I said already, right? So you can do the intercept as I said, right? You can do the same, right? The intercept. It's again the same thing, right? Look at this, right? This value, this divided by this one. It's not more than 2, so it's rubbish. It's not less than 5%, rubbish. Include 0, rubbish, right? So the same thing, okay? You don't need to worry about the formula. I'm not asking you the formula anyway. Now, once we're done, okay, we're going to talk about this data, okay? This data is very hot, okay? It's asking whether men earn more than women or women earn more than men. It's a very sensitive problem, right? And this is very fun analysis. We use the US data and have many households, and they have the panel, okay, 4 months, and then take a 8 months rest, and then 4 months. And then look at the weekly earning. Look at the data is 16 to 65. Only employed, self-employed excluded. Okay, so this is data. Okay, US data. So first, that's a very important thing, because you don't even talk in many classes, is how you handle the data. Okay, the first thing is do not use total wages, because it will be biased, because men work more than women in terms of hour, because many women, probably not in Hong Kong, but in US would have to take care of kid sometime. So they would not work that much. So in terms of hour, men will work more than women, okay, by just construction. But the reason why Hong Kong women can work that much because of there are a lot of domestic helper, which doesn't exist in the US. Okay, so of course in the US men also work less as well, but here it's like men and women work a lot, right? So but you not understand unless you go to the US, right? In Hong Kong probably don't have to do that, but in US to do it as well. Okay, and the data we show, okay, men earn 70% more than women in terms of hourly wages. Okay, then you will say unfair, woman's power, right? So let's see whether there's something justified. Okay, so this data, okay, men earn $24, women earn 20, right? So men are way bad, right? So men earn more. Why, right? Look at this. It's same across the board, right? Look at the median, 50, right? Men earn more than women, and the lower range also men earn the woman $2, $3, $6, $9, $10, right? Go understand what's going on. Okay, this is the data. And how to pull this data? You will be this NumPy and Panda. Okay, this is data, right? And then you do it. Okay, I'm not going to run it. Actually, I ran it last night already, but you can see the Python code over there. Okay, I'm not going to run this because of time. Okay, I just run over quickly for this one. So we look at the female. We know M.P where. Look at the gender. One is male. Yeah, one is okay. Two is female. One is male. The data. Okay, so that's why two. You put female is one, otherwise zero. Okay, the data. Two is female, one is male. Okay, I don't know, but this is what the US data. Okay, and we talk the wages. As I said, we normalize number of hours. So it's hour earned per week over how many hours they work per week. Okay, so average wages. Okay, and then group by the female, and you just look at the data, right? Okay, this is the describe. Maybe I should show the data, right? Although I don't want to run it. So the data look like this. You try to download it, it's a huge data set. Okay. Because there's a many micro level data. Okay. When you run it, it look like this. Okay. This is female, this is male, this is female, this is male, right? There's how many people are there in the data. What's the mean, SD, mean, max, this is data, right? So this is what we have. And okay. The second one thing is the wage difference may be due to the job, right? Because of probably it's wrong now, but it's old days, right? Who is going to do more computer science? Okay, used to be when I at my age is basically only men, no woman do computer science. It's not cool at that time, but of course now we see in this room many information technology manager here, right? So we have women, okay, as well, and doing marketing also a lot of high paying. So we have in the data actually maybe more men than women in this industry, so can explain because make it due to the choice, right? So that's why once we fix this job, we run the regression. And why you look at the log wages, not just wage, because of the wages also look like this shape. So we just log it and use robust standard error. Okay. Okay, that's what I do. I do np dot not numpy log it. I take a log. And then I focus on computer science. Okay, computer science in the US data have occupation number that is between 105 and 1240. Okay, you don't need to worry about that. This is coming from the data, so you don't have to understand what's going on, but this is what it is. Okay, that's CS. Okay, once you do this CS data, I just run the regression, right? Stats model from API is I run it using the log wages over female, okay? And see how female changes, okay? And the data will show you the beta is 14%, okay? Women make 40% less. Even if you look at CS, okay? You can ask your female classmate, do they make 40% less than you? Maybe someone is very unhappy right now. But this is US, okay? I think in Asia it's different. If Asia, I think male make less than female, which reverse, but I know. So the SC is like 0.08. The confidence interval is like this, okay? Then look and see, this doesn't include zero, right? So this is a real thing, okay? It's not coming from some random of data, right? So this is real, okay? So that means that the CR doesn't include zero. That is actually the gender gap, okay? Where's woman power, okay? So do I run the regression? I haven't run the regression, okay? Or let me show the regression here. How can I have not? Okay, the regression like this, okay? The regression result, this is 40%. This is SE. I should have copied this in the slide. I don't know why. How come I didn't? This is P value is less than 2. It's negative A, right? And the P is less than 5%. This doesn't include 0. So this thing is real. Okay? The 14% is something realistic. Okay? It's something we can keep this model. Okay? Let me finish one more slide and we have a break. Okay? Because I guess you also want to look at marketing job, right? Because some of you I know is doing marketing on IT, right? So look at marketing. So let's see if you have more men earn more, women earn more, or by how much. Okay, you do the same, but focus on data marketing, right? Because you just filter the data on marketing, right? So once you run the regression, I don't know why I didn't put the result here, but turn out to be marketing not that bad as computer science. Okay, and the same goes on. Okay, SC is this, but the interval includes 0. Okay, because this is positive, negative. So that turn out to be marketing. Woman and man doesn't make a difference because I expect marketing women make more, but because I think in general women talk better than men. That's women do better PPT than men. Okay, so that's why you compare my class to the other class, right? When you do the cost evaluation, you do the adjustment, right? Man in general is handicapped in presentation. So by construction, I do worse presentation than her, right? So to be fair, you should add more marks to me, right? Because so if you look at the data of the marketing, okay, that you expect, right? This is negative 11%, distant error. This set is not less than 2%. Sorry, not less than negative 2, right? And the p-value is not 5%, right? It's 6%, right? And this thing is including 0. So this gender gap is not, although we find 11%, right? But it doesn't say anything about the evidence not enough to say woman is worse in marketing, okay? At least computer science is very clear, okay? It's clear that men make more, okay? Of course, it doesn't still say a lot about the job nature, right? Because maybe the men are doing most crazy programming part, don't sleep, right? And women probably would want to have some better sleep, right? So they may, right? That's true, right? I mean, I guess so, right? Men don't care about their face, right? And for me, but maybe you care about a lot of face, then you will sleep a lot, right? That's true. So so you can do a star glazer, the same thing, and that gives you the result like this, okay? Once you look at star glazer, you will see we have 3 star in the female, but only one star is only 10%. So it's 11%, right? And that's why if not 2-star, they probably don't care. At least 2-star to be meaningful. Okay. And you have to look at R square as well, and R square doesn't really make a difference. Okay. You may ask why doesn't have 2 more star, because you have a very few number of in marketing. Okay. And you have more than around 5,000 in the CS, but 300 in the marketing. Okay. So that means you need more data for marketing to say this 11 is come from data or not. Okay. So let's see, have a break. Here we see, okay, if by standard 5% is what we do, but if you want to be more careful, you need 99. Okay. And if you are using big data, you should use 99.9 or even 99.999 or even further, because when big data by construction, it's always very easy to get p-value go to 0. Okay, you would use very strict rule when you do big data, right? Because remember what this is. This is type 1 error, right? How much tolerance type 1 error is, and you have large data, then you want to also avoid the type 2 error as well. Okay, because when sample size is very large, you can actually trade off type 1, type 2 error. So you would increase the alpha to, or reduce the alpha to very small. So in general, 5%, but big data, you would increase huge. Okay. Okay. And after the break, we talk about this prediction. Okay. So far, we just estimate a model, but we want to say more. Okay. Let's have a break of 15 minutes. Let's resume.哦，因為呢個係佢一個 deep learn 個反轉㗎，但我哋唔好寫落曲嘅。但如果你係其他科去搞呢個，你要做生態。係啊，唔使啊，佢又每個曲都歸得住佢。No，嗰個係 Y。Logistic 係 Y 係有時候應該先講，咁你呢個舊基數可以講埋。
laser 咩做 laser？ 係做嗰個嘢咩啫？幾多定？業務中有電，當然都冇人係。係啊，冇咗，因為 AI 而家你攞嚟我哋就攞嚟拋嚟。呢個，但係呢個都係要得嘅。呢個電我哋必須要得先。而家係我邊度講開有係所有開冇咗啦，俾小龍俾，我為佢自己做人。我依個，我只要講解。而且我都有嘅，新聞呢個。我哋批個中年我哋個價係中大最低，我哋並即間已經批翻佢大學房，係上啦。我下周上係我哋睇，我哋睇加兩，係啊，我都加二十，因為唔係中大我哋呢科係我哋佢話你係我哋呢科係事實接嘅係，都係我哋上次呢科係見咗我哋而家學有啲電視冇溝嘅，阿媽呢個係翻嚟翻一叫偷電真係多係多，但係屋企係多執翻嚟會如果你係M.P. 都40幾60分。
但係 fail 就係冇呢度啊嘛。先翻如果你講考嘅，即係如果有包含嘅話，即係係best 因為你有冇零有得要，冇零即係你同零冇分別啊嘛，即係咁你即係係啦，即係全部做咯，都跟住 gap 我俾。都唔係唔知會不力上嚟做，係啦，係同負二同負二中間就冇呢度咯，想大個一齊切大個為受，因為中間二啊嘛，佢哋二多佢兩 S， 大個係啊，沒有聊多，你可以從巴菲特來。哦，可能未真係未入到啊！我入到啊！
啱先我 lost 咗咧，即係啱先即係你所講95 CI 咧，佢中間如果 contain 有零，
咁咪即係嗰條嘢冇料到咯。
即係
點解冇料到？因為你有零，即係同零冇分別啦嘛。你包括零，
即係你個 data
你估嘢有零噶嘛？即係你嗰樣嘢同零冇分別啦。
係。
但係
即係話
個
data
唔係即係網上即係你個 data 唔夠咯，再多啲 data 啦。
哦，夠
Give me more data。OK。
即係佢零就即係代表冇 data。
唔係啊，因為你估入邊，你估有，
即係你話呢個佢係有包括零噶嘛？咁即係話你要51嘅話，都係唔係好夠，唔係好足夠強啦個 data，即係仲係唔夠多咯。你再擴咧多啲 data，諗住做咁佢先會確認。
哦，咁即係其實呢個係冇料到。
咁呢個即係咁，因為包括零，但係呢個其實都幾大下嘅，但係佢真係冇料到啊嘛，真係有。你除咗做多幾下，整到佢呢個唔係冇包含零。
總之是但一個呢個就係2啦，呢個0.5啦，同埋呢個。是
冇
但有一個唔符合標準都唔得。
係一樣噶，3個都。
是但係咯，
三個
有一個真係兩個
發生嘅，因為三
個3個都同一樣嘢嚟嘅，
即係3個一係全部中，一係
係冇可能嗰個做唔得，個另外一個唔做，全部一齊做，同一樣嘢嚟啫嘛。
咁呢個其實係 standard error。
呢個 scenario
啊嘛，
呢個除呢個係呢個啦。column one 除 column two 定 column three？你計呢個 column three 嗰陣時，係咪大過細過2就計係咪輸過0？基本上0.5%，或者睇呢個係咪有包括？
哦，即係其實呢個5%就係嗰個 confidence interval
就係呢個係
以外嘅。
係啦，係啦就係嘅。
即係呢個就95% 以內，呢個就係5%。
5%就90都係一樣。
係咯，即係同我其實一樣咯。
同一樣嘢嚟嘅。但係呢個係 interval estimate 喎，呢個係 focus testing 嚟嘅，所以但係都同一樣嘢。
嗱，可以話即係如果當呢個係零嘅話，咁呢個就一定
係啊，呢個係零，一定係唔包括零。
哦，即係如果呢個唔等於零，呢個就一定係廢。
係啊。
你都 set 唔夠大。
即係其實簡單啲嚟講，睇呢個係零嘅話，咁就 OK 啦。
係啊，冇錯。
咪就係睇嗰幾個標準咯。你見到嗰個0.95 CI 嗰度咧，你見唔見到個 range 之間係包含零啊？
係啊。
咁啊，即係唔夠大咯。佢嘅意思就係咁樣咯。咁所以你要個 data set 再大啲，即係 collect 多啲數據。佢意思係
係啦，即係你唔夠證據咯，翻嚟再做咁多數據再嚟等下啦。通常就係咁啦。如果你做 A/B test 都係咁啫。你如果公司做 A/B test 唔夠你咪個 collect data 做到夠為止咯。你做
sample
嚇？
係咪啊？
唔係你再 collect data 啫嘛，再做多幾 A/B test 啊嘛。
即係做到夠為止。
做到夠為止咯。正常就係咁做，你個 business 係咪先？
我諗緊我就咁樣做嗰啲叫 sample，即係因為你 data set 唔夠大。
冇，咁你都係要話 data set 嘅，唔好理。你 resample 嗰啲 bootstrap 係搞呢嚿嘢㗎嘛？
係啊，
但係你唔係呢度可以拍得到。你通常用，如果你用 bootstrap 計咧，呢啲會快啲。如果 bootstrap 快通常正常情況之下，但係我哋冇教呢樣嘢，但係可以 bootstrap，即係你揾 data 買個 regression， 我100萬次 regression， 咁咪計數100萬個 standard deviation 可以做，啲人都可以做。我哋冇教嗰樣嘢，但係其實可以咁做，即係啲 regression 你可以有計佢。
因為你可以跑你嘅 data resample 100萬次，咁咪100萬個 regression， 100萬 regression 咪有100萬個 standard error 嘅，咁樣計下有佢95個95%包括一樣100萬個 regression 係咪95萬個 regression 裏邊都冇零？你要同一樣嘢嚟嘅。
咁但係你要睇呢啲係咪真係
但係 sample 個概念唔係話個 data set 跑大嗰陣時再同呢樣嘢
唔係 data set 唔夠大，你係 estimate error， 想話先佢 normal 啫。因為我哋呢個話先佢 normal 㗎嘛。嗱，你唔想話佢 normal 嘅，就咁個 data 就100萬次咯，咪計到 error。
但係你咁樣做咪搞到計算咗？
你個電腦做幾快嘅啫，好易非常嘅，唔使擔心，100萬次都好快嘅。你撳一下可能15分鐘之後就100萬個10分鐘我都做。如果你呢部機嘅話，通常冇100萬個嘅，你10萬個都夠嘅。咁咪即係話呢個係難選擇幾多錢啦？呢個唔係你依佢嘅呢個嘅難選擇幾多錢？咁呢個咪少10%。
呢個係
係啊。因為 lock 咗個 base 去 E 段呢個嘅時候 exponential 2.78翻呢度嘅。又 lock 咗啦。
So let's talk. So maybe we can start. So what we just said before the break is to try to see if our model would be useful, right? Is whether the alpha are different from 0 or not, and beta different from 0 or not, right? If beta different from 0, your model is rubbish, right? Because if beta cannot distinguish from 0, then why you need x, right? Just use fh right, then you're done, right? The beta have to be different from 0 for your model to be meaningful, okay? Once you have that, now we can use the model, right? Once your model pass through the idea that the beta is not 0, then you can start to use the model, right? And how to use the model? Your model is like this line, right? You have to intercept the slope, right? So, but remember, we're not interested in this, right? Because we want to use x to predict y, right? That's the goal, right? It's not just to draw a line and we're done, right? The thing is, this model will tell us, you give me x, this is my y, right? But this only gives me 1 point, right? This is my x and my y. But we want to say not just 1 point, but rather a bunch of points, right? So here comes confidence interval, right? So you would add minus 2 SE. This is a crazy formula. No one ever remember anyway. So just put there in case you care, but I don't think anyone care because we will ask Python, the Python give us the result. So, I mean, if you really care, this is what, actually this is the formula I taught undergrad, okay? And in case you're interested, you can November in the undergraduate class I teach how to derive that, but we're not undergrad class, right? We understand what's going on there, right? So let's forget about that. So that's how to do the model here. So your data, you run the regression, you feed it, okay? Once you did that, what we're going to do is to predict, okay? So in order to predict, what I'm going to do is, because I want to draw the thing, so I would use a function called NP dot linear space. What I'm doing is, because I want to plot different x and different y, right? So what I'm doing here is the following. Okay, let me show the code. What I'm doing is, because I have this point, right? I have this line already. I know the intercept. I know the beta, right? This common data. Okay. Then what I'm going to do is actually look at the minimum x, which is here, x dot mean, right? And I also look at x dot max, okay? And I want to draw the line that I want to find 100 point here, right? So I minimum, maximum, I find 100 point. So that is a nice space doing, okay? That is, I want 100, I divide it into 100 point, okay? That is x mean, x max 100, right? I find the point in between, and I add a constant there, okay? And I use the regression to get the prediction of the x, right? So that means that I have 100 point here from minimum to maximum, right? Right. What I do is I have point number one, right? And then I just align there. I just get all the point here. Okay. Once I did that, right? Why I want to care about that? Because of course, I can. If you want, you can have as many as 1,000 or 1 billion and so forth. Up to you. Okay. And prediction. Well, I want to do that because I want to predict where it is. Okay. It's called the predicted mean. Is where you because when you do the prediction, they have many things. Okay. The predicted mean will be the one we want. Okay. And then once we did that, we want to calculate confidence level. Okay. And I want 95%. Okay. And I want this will give me two numbers. One is the zero column is low interval. The upper column is high interval. Okay. So you don't have to ask me why this, because this is because the output of the structure, the data, the output. So you have, no matter what you do, this is the standard method. Okay. And why this? Because this is output from the program. You have to do this to get what you want. Okay. So even if you do it on your own, you just copy this code, right? The only thing you might change, if you want, just you don't want 95, you want 99, right? Or you don't want 100, you want 1,000. That's the only thing you can. That's the only two things you can do. But nothing you can do more. This code is always copy and paste, right? I mean, I don't understand. I mean, they should have a function to do it once and for all. Someone should create a function, but so far no one do it, right? But if you want, you can create and add to the package. But this is something we want. Okay. Once I did it, okay, what I'm doing is not something too crazy. Is I have a matplotlib here. I use a scatter plot to use the blue color to plot the data, and I use the line I create to draw a regression line, right? And then I create the interval there, right? For each x, I have different y. And that will give us a confidence interval. And I draw it. This is standard label y, right? So what you get is something like this, right? I have a line there. I have data point here, and I have the interval here. Okay. Then what is this? Okay. This means that if 4 is my result, then this is my range. Okay. You're saying that, okay, if I give me 4, my prediction with the red line. This is my point estimate. Okay. But if I want to say I don't want to care about just point, I want 95%, this is something I guess. Okay. And you will see the shape will be like concave inside, right? Something like this. It's like a smile here and a sad face here. You may ask why. Always like this, because at the center of data is very accurate. Because here at the center of data, right? X bar and Y bar, right? At center data, this is the smallest. The further away from X bar, you will get fatter. Okay. that is always like this. So it will be very narrow at the middle, much fatter at the two ends. Okay, this is general thing we expect to see. Okay, of course, it's not always the case, but in general, that's what you observe data. In the middle, you have most data, so it's very narrow. The further away from the mean of data, then you get less sure what's going on, right? Because that is what regression is supposed to do, right? In the middle is expect. Okay, so this is a full model, right? So this is actually, if you're aware, this is exactly what you want to see when you see the typhoon signal satellite picture, right? This is the main. Oh, okay. You don't believe? Okay, let's go back to this. Some people think I'm crazy, but so this is exactly what I said, right? You have a main line, usually the main line over there, then there's a control map, right? But they show many percentage there. Okay, but usually in our case, we just show 90%. Maybe I look at the Hong Kong one, right? Because this is something. Do we have anything Hong Kong? Let's see. Because there's something that you know better. Oh yeah, this is the one. If you remember, this is the same thing. But of course, it's two-dimensional, right? The most of thing are here, right? Right. This is the most of the typhoon is most likely is here, right? Same idea. 90% is here, right? You don't estimate one path, but you estimate a bunch of paths. Why? Because they would never get fire, right? If you estimate as big as you want, then always true, right? If I said the typhoon will be on the earth, right? It's always true, right? People know the famous quotation, John Maynard Keynes, who said, in the long run, we're all dead, right? It's always true, right? No one survive forever, right? Even the new technology only allow you to 150 years old, right? So you cannot live forever unless you're a vampire, right? So, I mean, you can make it as big as possible, right? Of course, now the computer is really pretty accurate, right? But anyway, that's the idea. So it just why you want to give confidence, right? Because you give a large enough confidence, then you're never wrong, right? Or you have high confidence, it's going to be there, right? And do note that your confidence depends on data quality, right? Your data is very accurate and the band is very narrow, then actually tell us how good is your data. Remember the first thing, right? Why we care about variance or standard deviation is tell us how accurate your prediction is, right? The first class, right? Statistics. You learn mean, median, mode, right? That is the summary statistics, most important part of the data. But how good are the mean, median, mode? Look at the variance and standard deviation. Same idea here. Your prediction is a line, it's the mean estimate. You want to go 2SE up and down, this is what it is. Okay? And you can do the same, and then you can look at the earning as well. Looking at the marketing, okay? Occupation, and you just run the marketing data, all right? And you look at the regression, okay? And what I'm running, okay, is now I want to see, okay, the marketing data, I want to explain wage by experience, right? Experience is captured by age, right? So because in a lot of data, when you look at the wage income data, you can ask experience, and usually experience is by age. Okay, usually the older you are, then you earn more. Okay, so that's the case for marketing. So look at the data of this is turned out to be it's wage, log wage. This age is 14%, sorry, 1%, 1.5%, right? And it's 3-star here. 3-star here means less than 1%. So this is a valid thing. This is valid. And we're saying that if you survive for 1 more year on your job, even though you do nothing, you are lying down, okay? You earn 1.5% increment of your wage, right? Because the right-hand side is the wage, right? 1 more year experience, you should go up by 1.5% of your income, okay? So this marketing people earn more, okay? And the other thing is you want to do some plotting. So there's a code, again, just memorize, is we will got the regression and got the summary frame. I don't know why I do that, but anyway, this is the code to get the table. You get the prediction data, and you combine it, you combine it with original data, okay? And then I want to focus on the wage is not too large and not too big, okay? Within 2 and 4.4. And then I want to sort them by ages, okay? And once I do that, I predict X and Y to predict the CI lower and CI upper, okay? And I just add a bunch of this thing, okay? Then you will see this data, okay? And this is the line, regression line, looking at the ages, okay? And this is wage, right? So it seems to be very noisy, but turn out to be, it's pretty good slope over there, right? So, okay, of course, it does have 6TA and not so much, right? But in general, you will see a line there, okay? So it's a general trend that you have more experience, then you earn more, okay? Is that okay? So there's something is pink, but I just mentioned I don't want to go into detail, okay? Because if you do undergrad, there will be something here is so far, remember what's the regression? The regression is telling you the average value of Y given X, right? You predicted the average value of Y. You're not measuring individuals, okay? If you do individual, you need another formula, which is called prediction interval, okay? And you look at the formula that prediction, because you're not measuring average, you're measuring individual. Individual will have more variation than the group, okay? Because what does that mean? It means that, for example, in this interval is asking if I grab a bunch of 40 years old people, average wages will follow within this range, right? But if I pick one guy, not the average, what should be the range? That's called prediction interval, okay? But I skip that from my class, okay? But if you remember undergrad, it's already included. But the formula is not very complicated, okay? Because you just have one more one there, okay? And you can also do it just in the Python is not mean, it's called observation CI. The mean CI will be the average CI. Is CI, this is called PI, okay? Prediction interval, okay? Just another number there. And you will see, look at data, basically, it's very thick horizon, okay? If you prepare individual, it's much more variation, okay? Than the data that you want to predict, okay? So it's usually, unless you care about individual, then otherwise this is something not often you use anyway. So most of the time you use CI, we don't use PI that much. So that's why I cut it out. And I want to include that because in many textbook, undergrad textbook, they would have talked about too. But I guess at our master level, we are good enough to forget about this, right? But I just mentioned it because when you read the textbook, you will see when they mention CI and PI, then you will confuse what we are talking about. Just to remind you, the CI is the average value, PI is individual. Okay, and very often we care about average rather than individual, right? We care about the average income of that group rather than individual, right? If individual has much more variation, okay, but I don't think you would be care too much about that part. Okay. One thing to note at the end is how when we run a regression, we get the nice result, we got the interval, we get everything there, right? We have a nice model, not just a point. We have a bunch of points, a bunch of lines, we get a very nice map, present to the management, right? The thing is, does it work in practice when it's outside the data you get, right? Just like the machine learning model, right? The model work well in sample, and out of the sample, it just, right? Very bad, right? Very often like this, right? It's overfitting, right? So the question is whether your data will work, right? I mean, remember the first class, GIGO, right? Giggle, right? So if your data is garbage, then doesn't help, right? So no matter what kind of regression or machine learning you're using, your data doesn't work, right? So we have to collect the right data, right? So you try additional data, right? And someone asks, okay, if I don't get my star in my regression or my regression, the P is almost 5%, but not that so, right? Then how you do? Collect more data, right? When you go to work, you do A/B tests, you find it very nice result, but barely significant. Okay, just do more, right? That is a standard thing in the business, right? So that is what you would be doing. Okay. So very quickly, we can do multiple regression. Don't worry, we'll not finish it, but we just touch on this somewhat. Okay. Multiple regression. Okay. So far, our life is only be involved in one single variable. Okay. But can we extend to more? Well, actually, you do it in your machine learning class. Right? Machine learning class's problem is you have way more regressor than we want, right? So the question is, some of you ask, oh, in this class, if I have only 2 or 3 variable, can I do? Yes, of course. We're not machine learning class, right? So even you have 1 variable, it's okay, right? If you tell the story, right? But is it more the better? No, I told you, right? Not more the better, right? You learn machine learning, right? You do the LISO, right? More can be worse, right? Cannot be better. So that's why you use LISO enrich to reduce the dimension, right? And the same idea is minimize the vertical distance between what you predict and what the data is, right? This is same, right? Before you don't have this guy, these two, right? Now you have more, but that's no different, right? Instead of fitting, imagine it's a line and a dot in 2-dimensional space, right? You can imagine 3-dimensional. It's easy to think about 3-dimensional. Imagine y is vertical, okay? And x1 is here, x2 is here, right? The many points live in this space. The many point here, okay? And then what you're going to do is to fit a line in this dimension. Actually, the plane, right? The plane. There's a dot here. And then dot here. You try to fit the plane. Each plane you have a dot. Suppose there's a dot here. The distance to the pole, distance to the plane. See, right? The y is vertical. So this is this point. This is x. This is x1 and this is x2, and y is here. x1, x2, and here. Okay. The distance from this is x1. Distance from that is x2, and height is y. And you try to fit a plane here. The plane is to move around. Distance to the point is minimized. You imagine this as the dot. Okay. You have to minimize all these points. Okay. But of course, this is 2-dimension, but you can more than that. Is that clear? I don't know whether you clear. Okay. But of course, you can't imagine it more than 3-dimensional. If 4-dimensional, I don't think anyone can imagine that. Okay. But in the math, that's no problem. Okay. You can easily go to 4-dimensional. So I don't want to talk about this estimation. It will involve some matrix algebra. Okay. And there's some way to solve it. Okay. You're not math class, so just forget about it. Okay. And one thing I need to mention, probably you know as well, is if you include different variable, it's so similar, your regression is bad. Okay. Why is the case? Please just tell me, right? Why is the case? If I have many variable, okay? If 2 variables are so very similar to each other, why would it be bad to include both of them? Okay. Why? You learn it from a machine learning class, right? Why? Yeah, more or less. Because if they're so similar, how can you distinguish which is causing which? You create some trouble. Say suppose they're the same, how can you put weight on it? Okay. Whether you suppose they're jointly contribute to it to the same, then right? Is it going to suppose the effect is increased? Say suppose x1 and x2, okay? They move all the time the same. Okay. If you increase x1, x2 always increase the same amount. Okay. That's exactly the same thing. Then if say x1 increased by 1 and x2 increased by 1 as well, then it say suppose they increase, y also increase, right? Then how can you run the regression? Because you can't tell what's beta 1 and beta 2, right? Because you can always increase beta 1 and reduce beta 2 by the same amount, the same thing. So you can't identify because they're so similar, right? You can't tell which is cause, which you can't tell what happened, right? Say suppose you always take Chinese medicine and Western medicine together, right? Then how can you tell which is curing you, right? Or which is killing you, right? So you don't know. You always take the same thing, and then they're doing the same job, and then you always do the same. Then you can't tell, right? You can only tell if sometimes you take it, sometimes you don't take it, right? So you have some uncorrelated, not so correlated, then you can tell, right? You can't really distinguish the two, right? If they together, right? So if they always go together, you never know, right? Just like I think it's a famous thing, right? After you get married, right? You don't know what's love, right? The reason is because you always with your partner, then you don't know what's the value of that. Unless you separate a bit, then you know what's the value, right? That is it's not loving, just what I said, right? It's 小別勝新婚, right? Just you separate a little bit, then you know what's going on, right? You always with that. I think that's a song, right? Only if you know the value, meaning of life, unless you have challenge in your life, right? That's the same idea. So because you're always successful, then you don't know what is not successful, right? If you always success your life, then it's not going to tell you don't know how to be successful, right? Because you don't know what's fail. The same idea here. Okay. So now, the very last part is look at this again, our wage data. Okay. Remember the wage, one the female, okay, female earn less. And then look at wage and age. We know that wage and age are positively related, right? Because you are more experienced, you have a higher salary. Okay. But we actually want to do it together. Why? Because usually female are younger in the labor force. Why? Because female retire earlier, right? The retirement age of female, at least in China, is 5 years earlier than men, right? And in US also, right? Men retire later, right? So that is the reason why you want to run this, right? Okay, because age will explain. So the same thing goes on. Age, working hour, only for employee, and looking for college above, they spend more time. Okay, and then download data. I'm not going to go again. Look at the female wage over the hours. Look at the log wage as well. So we have done that already. Look at observation. At least 20 hours. Make more than 0. Age is between 24 and 64, and it's just have college degree, I think, more than 44. Okay, and I run. Oh, but quickly we're done. Okay, and then we will be looking at the female and age. Look at the result. I'm done. Okay, and just okay, and this is a result. Okay, you will see without the age, women make 20% less. But with age or experience, actually this reduce, right? As expect, because age explains some of that. Age is already included in here. So if you omit many things, you get a lot of things here. So the next week, we'll include more stuff. We'll tell you that this actually shrink a lot, okay? So the age gap actually is not that much if you include more stuff. So that's why you don't want to run simple regression. You really want to want more, and that might explain a lot, okay? And that's today, okay? I overrun by 1 minute, so next class I will reduce by 0 minutes, 9:30. But I reduce 1 minute, okay?